dear students, welcome to this series on mathematics. Today we are going to look at the chapter called Nature of Quadratic Roots for grade 11 in the syllabus of additional mathematics. You have learned about quadratic equation at Form 5 level already, or even at Form 3, Form 4 level. Now we are going to analyze the roots. We are interested in the roots of those quadratic equations. If I ask you to solve x squared minus 5x plus 6 equal to 0, you can do that together with me. Second, I ask you to solve x squared minus 4x plus 4 equal to 0. Use factorization, use quadratic formula, whichever method you are at ease with. So solve these two. Third, solve x squared plus x plus 1 equal to 0. What do you notice? What's the answer for the first one? X equal to 2, x equal to 3. Here, x equal to 2, x equal to 2. And here, you are unable to find x. X is not real, that is, it is imaginary. Could we have predicted these roots? Can we know beforehand that this equation will not have a real root or will not have real roots? That this equation will have two equal and real roots, and this will have two real but distinct or different roots? Yes, we can. But before we reach that stage, let's see what happened to the graph. If you plot the graph of y is equal to x squared minus 5x plus 6, what are we saying? That this graph cuts x-axis at x equal to 2 and x equal to 3. Of course, because the coefficient of x squared is positive, that's why we get the shape. If the coefficient of x squared would have been negative, the shape would have been inverted. For this one, x-axis is a tangent. And here, the curve does not touch the x-axis or cut the x-axis. That's why the root does not exist here. So what is a root? A root is that value of x where the graph would actually cut the x-axis. Here I have two distinct roots, 2 and 3. Here I have two real and equal roots. Here, the graph does not cut x-axis, is completely above in that case. Therefore, the roots are said to be imaginary. Can I predict that? That's the whole aim of this chapter. Yes, we can. How? For any quadratic equation, we calculate the discriminant, which we also write as dis or using a triangle. It is given by the coefficient of x, which we represent by b squared minus 4. I usually like to write that in a bracket. 4 times the coefficient of x squared times the constant. Remember, here, everything which is in front of x squared is represented by a. Everything which is in front of x is represented by b. And everything else is represented by c, the constant term. That's the discriminant, b squared minus 4ac. So, if we come here, the roots are real. That is the curve we see where the curve cuts x-axis. They are real and distinct. Real and distinct. So, in this case, the discriminant is always positive, greater than 0. So, if the discriminant is greater than 0, then the roots will be real and distinct. Here, roots are real and equal. Roots are real. Yes, it's real. We can see where it touches the x-axis, but they're equal. So here, discriminant is equal to 0. In this case, real roots don't exist. Roots are imaginary. Discriminant is negative. Now, very often we can combine these two and we call them real roots, for which discriminant is greater or equal to 0. So, if you're given a quadratic equation, what's the first thing you will do? Calculate discriminant. The discriminant is b squared minus 4ac. Everything in front of x, the coefficient of x, is called b. The coefficient of x squared, everything written in front of x squared is called a. And the remaining would be the constant. So the discriminant is obtained by squaring b squared minus 4ac. If the discriminant is positive greater than 0, then we know that the roots are real and distinct. If the discriminant is equal to 0, then we know the roots are real and equal. If the discriminant is negative, then we know that the roots are imaginary. That is, the curve will neither touch nor cut the x-axis. So, these are the rules that you need to remember on nature of quadratic roots. I would like you now to calculate the discriminant for each one of them for me. And for this one, you must get a positive value. If you do it, what is a here? A is 1. What is b here? Minus 5. What is c here? 6. If you calculate the discriminant, which is b squared minus 4ac, it gives you minus 5 squared, 4 times 1 times 6. So 25 minus 24, which is 1, which is positive. So the discriminant of this equation was positive, and therefore I would have immediately concluded that the roots are real and distinct. If you calculate the discriminant of the second one, what would you expect? you would expect to get 0, so that the roots will be real and equal. If you calculate the discriminant of this one, you expect to get a negative number. So we are now going to take an example while you calculate the discriminant. Okay. Now, the question is, what would be the value of C if I want the roots to be real and equal? Roots are real and equal. So, as we said, first step, calculate the discriminant. What is A here? 1. What is B here? -4. And C. So we calculate discriminant. What is discriminant? B squared minus 4AC. Be careful here. B is -4. If you write -4 squared, you'll have a tendency to write -16. So it is -4 into bracket to the squared, 4 times 1 times C. So this is 16 minus 4C. Now what is the rule? Discriminant equal to 0 if roots are real and equal. So the discriminant for C equal to 16, C is equal to 4. So C is equal to 4 if I want the roots to be real and equal. What would be the values of C if I want the roots to be real and distinct? So the question is, what would be the values of C if I want the roots of this quadratic equation to be real and distinct? So again, we are going to calculate the discriminant. As you have seen, the discriminant is equal to 16 minus 4C. What is the rule? Discriminant is greater than 0 if roots are real and distinct. So I'm going to solve the inequality, discriminant is greater than 0, which gives me 16 minus 4C greater than 0, minus 4C greater than minus 16. I divide by minus 4. Remember, when we divide by a negative number, the inequality sign is reversed. So this means, what is the answer? If C is less than 4, roots will be real and distinct. Third, what would be the values of C if roots are imaginary? Again, we start by calculating the discriminant, which we have already done. 16 minus 4c. What is the rule? Discriminant is less than 0, that is negative, if roots are imaginary. If roots are imaginary. Therefore, 16 minus 4c is less than 0. Minus 4c is less than minus 16. I'm going to divide by minus 4 by a negative number, so we reverse the sign. So the answer is, if c takes any value greater than 4, roots will be imaginary. So, if c is equal to 4, exactly equal to 4, this quadratic equation will have real and equal roots. If c is less than 4, you choose c less than 4, any number less than 4, then the roots will be real and distinct. If you choose c to be greater than 4, then the roots will be imaginary. Now, in other questions, you may also have the discriminant, which is a quadratic equation. So we'll follow the same procedure to solve quadratic inequalities in order to answer this question. Therefore, my dear students, we have looked at nature of quadratic roots. We looked at how to calculate discriminant. This allows you to know in advance what the roots of the quadratic equation are likely to be. Three things: real and distinct, real and equal, or imaginary roots. So, we have also taken an example of a typical exam question that shows how to apply whatever we have learned. In the second part, we are going to see the application of the nature of the roots. So till then, it's goodbye from us.